All right, today we are going to wrap up our comparing bits and pieces investigation 3 with lesson 3.5, which is basically moving from a fraction to a decimal. And so we're going to really be talking about why it makes sense to divide the numerator by the denominator to find an equivalent decimal. All right, so let's move down here. It says, on January 12, 2010, a 7.0 magnitude earthquake struck the country of Haiti. It destroyed many homes and caused major damage. Many people had no place to live and little clothing and food. In response, people from all over the world collected clothing, household items, and food to send to the victims of the earthquake. Students at a middle school decided to collect food to distribute to families whose homes were destroyed. They packed what that was collected into boxes and sent to families. The students had to solve some problems as they packed boxes. As you work this problem, we need to ask ourselves, when is a decimal or fraction more useful and why? So, moving on to the problem, we are going to focus on questions A1 and A2, and before you come to class tomorrow, you need to make sure that you have question A3 done before you come to class. And I know I just said you need to get it done before you come to class, but it's really important that you have it done before you come to class so that we can get started when you get here. So let's take a look at question A1. A1 says, each grade was assigned different numbers of families for which to pack boxes. Each grade shared the supplies equally among the families they were assigned. They had bags and plastic containers to repack items for individual boxes. They also had a digital scale that measured in kilograms and grams. The sixth graders are packing 6 boxes. Okay. How much of each item should the students include in each box? Write your answer as a fraction and as a decimal. So let's take a look. If we start A1 and we look at powdered milk, okay. So right here, we have 13 grams of powdered milk. Well, how would I divide that evenly into 6 equal groups? Well, I simply would divide it by 6. Well, in order to do that, we are going to take 13 divided by 6, and that equals 2. And we have 1 left over. Now, instead of saying remainder 1, we've got to have some way of showing that remainder. So what we're going to do is this 1 becomes a numerator because it's a part that's left, and the 6 out here becomes our denominator because it was what was the whole. And so one way of showing this would be that they would get 2 and 1/6 kilograms of powdered milk. Now, another way that we can show this real quick is by saying we had 13 grams, or kilograms, I guess. So I said it wrong up here. 13 kilograms of powdered milk. We're dividing it equally amongst 6 boxes. That would give us the fraction of 13 over 6, which when we reduce that, we would get 2 1/6. So 2 different methods for doing that. Now, this is where we take the numerator. Okay, now how to get it? Let me rephrase that. In order to turn the fraction part into a decimal part, like what it's asking for, we're going to take this form, the 13 over 6, and we are going to take the denominator and use it to divide the numerator. Now, because it will not, we already know it won't go in there evenly, we have to add a decimal and a 0, and then we bring the decimal straight up. So that's the first step. Now we're ready to solve. So 13 can go, or 6 can go into 13 2 times. We're left with a 12. We subtract. We get 1, and then we bring down our 0. So 6 can go into 10 1 time. Need to scroll down the page just a little bit. Okay, so that'd be 6. We subtract, we get 4. Now we can go ahead and add another 0. We can add zeros to this 13 as many times as it takes until we find out if the decimal repeats or terminates. Repeat mean that it would repeat the pattern. Terminate means that it would stop. So we bring down the 0. We now have 40. 6 can go into 40 6 times. We're left with 36. We're left with a 4. Now, what does this show me? Okay, I can stop right here because if I have a 4, I had a 4 up here, my next decimal point is going to be a 6. So that means our decimal equivalent would be 2.16 with a line. We call that bar notation over the 6 because that 6 will repeat. So this is roughly, we can round that to get us a better answer. So that'd be 2.17 or 2 17/100 kilograms. Okay, now to show this again, let's go ahead and take the crackers. Let's go over here and let's take our crackers. So for crackers, we've got 3 kilograms. And again, we're dividing that by 6 boxes, okay? And so this looks like a fraction 3/6. So that would be 3/6. We reduce that down by dividing it by 3 over 3, and that would give us the fraction 1/2. So each box is going to get 1/2 of a kilogram. To show the division, we're going to do the same thing to turn it into a decimal. We're going to take the numerator and divide it by the denominator. We're going to add a decimal and a 0 and bring up our decimal. So 6 can't go into 3 as a whole, but it could go into 3 as a part. So that decimal right there separates the whole numbers from the part. All right, so 6 can go into 3 with a 0, which would look like a 30 5 times. You get 30. We subtract, we get a 0 left over, so that would be equal to 0.5 kilograms. All right, and we're going to follow a very similar thing for oranges. Okay, the oranges we're going to take, we have 24 kilograms of oranges. We're going to divide it by the 6 boxes, which would equal 24 over 6, which when we reduce both of those by 6, we get 4 over 1. So then we would have 4 kilograms of oranges. Okay, and we can do the same thing with the division. If we took our numerator and divided it by our denominator, whoops, that's not our denominator. Our denominator is 6. Denominator is 6. 6 can go into 24 4 times, and the answer is 4 kilograms. All right, so that's how we would do that. Now what we're going to do is we're going to come down here, and Mary says that 13 over 6 or 13.6 kilograms of milk goes into each box. Melik says that 2 1/6 kilograms goes in, and he used his benchmark list to rewrite the amount as 2.16 kilograms. Funda says she divided the amount of milk by 6 and got 2.167. With whom do we agree and why? Well, let's take a look over here at all of our calculations for the powdered milk. Okay, I'm going to switch to my highlighter real quick so that we can highlight the things that we see that are similar. So we're looking for 13.6 right now. So if I look over here, I see 13.6. So that's one way of writing the fraction. That would be our improper fraction. Okay, let's go. 2 1/6. Let's see if we see that over here. We do. It's right here. Okay, so that again is their equivalent fractions. Okay, so let's go on to 2.16 kilograms. And right here we have 2.16. So 2.16 would also be an acceptable way to write this. And then we have Funda, and Funda says that she got 2.167. Well, when I use these little squiggly lines right here, that's what Funda did, but instead of rounding it to the nearest hundredth place, see, we rounded it to the nearest hundredth. This is the hundredths place. Whoops, that makes it look like it's going off over there towards the tenths. This is the hundredths place. So what Funda did was she said, since the 6 repeats forever, that we would round it to there. So 2.1666 ... is going to be equal to 2.167 because we want to round it up to where it quits. Okay, so again, Funda is also correct because 2.167 is going to be another way of writing. Okay, so they're all correct because they're all equivalent ways of writing the same number. We have an improper fraction and a proper fraction, or a mixed number, and then we've got a decimal that we just stopped the repetition, and then we have a decimal where we rounded up to terminate the repetition. So now what I would like for you to do before coming to class tomorrow is take a look at number 3 again and decide whether or not Scooter is correct in his ratio of oranges. See you in class.